Okay, so let's go ahead and find a general formula for the sum of the first n terms in a geometric series expansion. So let's just generally define as a sub n, okay? And we have a geometric and we want to keep it as generalized as possible. So we know it's going to start off with some constant, and then you're multiplying each time by a ratio, r. Okay, so the second term in the counting sequence would be AR, and then it would be AR squared and AR cubed and so on and so forth. Okay, and it would go all the way to the AR to the n minus 1. Okay, this would be technically AR to the 0, AR to the 1, AR to the 2. So this is AR to the n minus 1. So first, second, third, fourth term, and nth term, okay, as it were. Okay, very good. So we have as a sum, therefore, we've got A. Here we've got A plus AR. Here we've got A plus AR squared, and so on and so forth, all the way to A plus AR plus, and then all the way out to AR to the n minus 1. Okay. Well, let's at this point go ahead and try to generalize this. If I have my sum S sub n, I can group all the a values together, as you can see, and I would have as follows: a, and then it would simply be 1 plus r squared plus all the way to r to the n minus 1. Okay, oops, wrong symbol. There we go. Okay, well, to try to find a generalized formula, let's just go ahead and multiply both sides by r and see what we get. So rsn equals all of this times r. Well, that's simply going to be a times r plus r squared plus r cubed plus all the way r to the n. Essentially, every value here gets multiplied by r. That wasn't so bad. Okay, let's now find s sub n minus r s sub n. Well, it's going to be all this minus all of this. So it's going to be a, and then 1 plus r squared plus all the way out to r to the n minus 1 minus, and then all of this. Okay, like so. Okay, good. Now, it's worth pointing out here, I can take an a out of everything, so why don't we start by doing that. And if I take an a out of everything, I have as follows. I've got 1 plus r squared plus all the way out to r to the n minus 1. But now I'm going to have minus basically everything in here. Minus r squared, minus r cubed, minus all the way to minus r to the n. Well, this is not going to be so hard to figure out. As we can see, everything is going to cancel out except the 1 minus r to the n. So I'm going to have as follows a, and then I'm going to have 1 minus r to the n. Okay. And now if I want to solve for s sub n, I can just factor it out, and then I'll have a 1 minus r here equals a times 1 minus r to the n. And now let's divide both sides by 1 minus r. That gives us an explicit formula here. Okay. Many of you know how this formula works. You use it all the time, but you don't really know why it works. Well, now we know both. And it's important that we do know both. Okay. Hopefully you enjoyed this video. As always, please leave comments, questions, recommendations for future content. We love mathematics around here. We love physics. We're going to try to derive and prove as many statements as we have time to so do. Meanwhile, have a great rest of your day, and we'll see you in the next video.